Hey guys, so today we're starting the first of 4 lessons that has to do with surface area and volume. Just like when you did this in grade 9, it's really important when you're doing this to show all of your steps, to label your diagram and your steps so that I can see which face of the shape you're solving for in each of the steps. So that you can get part marks, because it's really easy to make like a small mistake and end up with the wrong answer. Okay, so this is lesson 1.4, the surface area of pyramids and cones. It is important to note that when we're doing the surface area of pyramids and cones, you always need slant height, not height. And so what that means is if I have a pyramid like this, the height would be inside the shape like so. Essentially, it would be like if I have a pyramid, I'm just kind of showing two sides of the pyramid here, but if I had a pyramid like so, the height would be coming straight down out of the center, so straight down out of the center to the base. The slant height on the other side, I have my pyramid there, is coming down on the face. So it's not coming straight down out of the middle, it's coming down on the face. So the way we would represent that is the slant height would be right here or right here. So those would be the two possible slant heights. On a cone, like what we see over here, the height would once again be in the center of the cone coming straight down to the base, whereas the slant height would be over actually on the face of the cone. Okay, so it's really important when we're doing surface area that we're using these slant heights, not these kind of internal heights. You can convert between those two different types of height using Pythagorean theorem. So if you're given the height and you need the slant height, use Pythagorean theorem. And then as far as finding the surface area, we are of course just going to find the area of each face and add them together. Before you do that, make sure all your units are the same. You may need to convert your units before finding the surface areas. If you're asked for the lateral surface area, it means find the surface area not including the base. And if you're given the surface area, you can use that and your formulas in order to find another missing variable. These are the formulas that you're going to be using when it comes to surface area. You can see this says area formulas and not surface area formulas. That is important because these formulas are for each face of your shape, not the entire shape altogether. So for example, if we were finding the surface area of a cone, we would need to use the curved surface of the cone, but then also just a normal circle for the bottom of the cone. If we were doing our pyramid here, we would need to use the triangle area for each of these faces, and then the square for the base, okay? So you do need to kind of pick and choose which of these area formulas to use and then add them all together to get the full surface area. So we're going to start with this example here. I've given you a pyramid. It has a base of 4 by 6 and it has a height of 5 centimeters. So the first thing I check is that all of my units are the same, and they are. And then from there, I realized, okay, I have a height, but I need to be using slant height. So my very first step before I start finding any areas is to make sure that I have my slant heights. In this case, I am going to have to find two different slant heights. I'm going to have to find this slant height over here, which I will call S1 for slant 1. That slant height will be the same as the slant height on this face over here. Then I also need to find the slant height of the front of my pyramid right here, which would be the same as the slant height around the back. I'm going to call the front one slant 2. Okay, so slant 1. I am, of course, going to be using Pythagorean theorem. So a squared plus b squared equals c squared. In order to use Pythagorean theorem, we do need to have a right triangle. So my right triangle that I'm going to be using is right here. I'm going to be using the internal height of 5 centimeters. Here's my right angle, and I'm just going to go straight across like so over to my slant height to create that right triangle. Now I know this side of my right triangle is 5 centimeters. I'm going to be looking for the slant height, which, because it's across from the right angle, is my hypotenuse. And then this down here, many people would say that that is a length of 4, but it's not, because this line does not go the whole way across the base of this pyramid. It's only going halfway across, and therefore this is actually 2 centimeters, because this is half of this entire length here. So that is going to be 2 centimeters. Again, it's only going halfway across, so it is half of this length. So now I can plug those units in. So 5 squared plus 2 squared equals c squared. 5 squared plus 2 squared is 29. And then, of course, in order to get rid of that squared sign, I need to square root my 29, which leaves me with 5.385. And you do want to keep at least 2, if not 3 decimal places when doing this, because it's going to affect the area of that face. Okay, the next thing that I'm going to do is figure out what my slant 2 height is. And by the way, it is very important to label your slant heights both here where I'm calculating them and also on the face. People frequently, when they're doing their area calculations, use the wrong slant height. It's very easy to confuse, and I'll show you that once we get to it. But make sure that you're labeling your slant height both on the diagram and where you're actually doing the calculation. Okay, so once again, we have a squared plus b squared equals c squared. This time, the right triangle is a little harder to see just because of the perspective that we're using. But once again, we're going to be using this internal height of 5 centimeters. This time, we are using this slant, obviously, because that's the slant height we're supposed to find. And so our right triangle is going to be right here, using this height, this length, and then our slant height. If I were to rotate this 90 degrees, it would look like a right triangle like this, but it's coming out of the page towards you, which is why it doesn't really look like a right triangle. But try and picture this triangle right here coming out of the page towards you. Now, once again, this little base length of my right triangle here does not go the whole way to the back of this pyramid. It only goes halfway across the pyramid because it's just going to the center of the pyramid where this internal height comes down. So this distance right here is only half of the length that it's parallel to. So this is going to be 3 centimeters in there because it's half of 6. From there, I'm going to plug in my 5 squared for that side, my 3 squared, and once again, the slant height that I'm looking for is always going to be my hypotenuse. So I will do 5 squared plus 3 squared, which is 34, and then of course, square root it. and I will get 5.831 as my second slant height. Now that I have that, I can start actually finding the areas of my different faces. So I am going to call this face here, this entire face on the side here, I'm going to call that area 1. And then of course label that I'm finding area 1 over here. Because it is a triangle, I'm going to be using this formula, area equals half base times height. So half base times height. On this face here, my base is 6. So half of 6. And then my height is, of course, the slant height of that face, which is slant 1, which is 5.385. Now, this is where people often get confused because you may have noticed when I actually calculated my slant height number 1, I used half of this base. But that slant height, once I'm actually finding the area, goes with this base. So the base that you use half of to calculate your slant height is not the base you use with that slant height once you're calculating the area. And again, that's just because now that I'm calculating the area, I need the base of that face. But when I was finding the slant height, I was using half of the other base. Okay? So just, again, that's why it's super important to label your slant heights clearly, because people frequently would use the wrong slant height when calculating that face. Anyway, I am now going to do a half, so 0.5 times 6 times 5.385, and that gets me 16.155. And then because the two opposite sides of the pyramid are identical, I am going to multiply that by 2, and I get 32.31. I'm now going to circle that so I know that I need to add that later on. You'll notice I did not circle my slant heights because they're not actually an area measurement that needs to be added to the surface area. Okay, next up, I am now going to find the area of this entire front face here. I'm going to call that area 2. Once again, the formula, and I'm just going to kind of separate that out. The formula is half base times height. The base of this shape here, this front whole triangular face, is 4. And the slant height of that face, which is slant 2, is 5.831. I will then multiply those together, so 0.5 times 4 times 5.831, and I get 11.662. And then because the front and the very back of this pyramid would be the same, I'm going to multiply by 2, which gives me 23.324. I circle that so I know that I need to add it later. And now I have run out of space, but I'm not done yet. Next up, the very last area that I need to find is actually the base of this shape. Since I wasn't asked for the lateral surface area, I was actually asked for the actual surface area. So area number 3 is just the base. This is a rectangular base, so we'll just do length times width, which is 4 times 6, which is 24. And there's only one of those, so I don't need to multiply it by 2. My very last step then, which I will just call step number 4, is to find the surface area. And for that, I just add together everything I've circled. So my 32.31 plus 23.324 plus 24. And I get 79.6-ish. You can do 79.63 or 79.634. I'm fine with at the end having 1 to 2 decimal places. And don't forget your units. You've noticed I have not been writing my units the entire way through, but you do need to have, at the very least, your final answer with the correct units. Okay. Next up, I do want to try an example of a cone as well. So let's try that. Okay, so for the second example, I have given you a cone. I have drawn in that the diameter of the cone is 24 centimeters. And I've also told you that the surface area of the cone is 5,700 centimeters squared. So this one, we're actually going to be working backwards. And what I would like you to do is figure out what is the slant height of this cone. So that's what we're going to be looking for, is our slant height. Okay, so in order to work backwards like this, we're going to have to start by figuring out what the different formulas that we're using are. So in this case, I have the base of this cone, which is a circle. So I'm just going to call that area 1. And then I have the whole rest, the whole outside of the cone, which I'll call area number 2. So if I go over to my formulas over here, the whole surface area is going to be equal to the area of the bottom, so the area of that circle, which is pi r squared, that's what the area of the circle is equal to, and the area of the curved surface of a cone. So I'm also going to add the area of that curved surface, which is pi rs. In this case, the S standing for slant height. Now I'm just going to start plugging in the terms that I know. So I know that my surface area is 5,700. Pi is just going to stay as pi. My radius is just going to be half of my diameter. So since my diameter is 24, my radius will be 12. And then S is the variable that I don't know. That's what I'm going to be solving for. So my first thing I'm going to do is just figure out what pi times 12 squared is. So 12 squared is 144, and then I will multiply it by pi to get 452.39. And then 12 times pi is 37.699. And my S is still there. Nothing I can do about that. Now, I want to isolate my S, so I want to get the S by itself, which means everything else that is on the same side of the equal sign as the S needs to move to the other side. When I'm doing that, anytime I'm isolating a variable, I always start by moving whatever is furthest from the S. So in that case, that is my 452. So because this is a positive number, I will subtract 452.39 to get it to cancel out. And what I do to one side, I must do to the other. So I will subtract 452.39 from the other side. 5,700 minus 452.39 leaves me with 5,247.61. And that's going to be equal to my 37.699 S. Now that I have 37.699 times s, in order to move that number away from my variable, I need to divide 37.699 to get it to cancel out. And of course, what I do to one side, I must do to the other as well. That leaves me with just s on the right side. And if I divide that out, I get 139.2 centimeters as my slant height. And that would be my final answer. Okay, so we have looked at both cones and pyramids. We've done one where we find the surface area, the other one where we find a variable given the surface area. Honestly, the most difficult part of, I think, this entire chapter is probably the surface area of pyramids, just because people do get the slant heights confused. So again, just make sure you're showing all your steps and let me know if you have any questions.